Assalamualaikum and good day. My name is Nur Jafura, AE190126 from Group 2. Today we will present our assignment 2. So for the introduction, a temperature control system is a control system that uses a temperature sensor, a controller, and a cooling system to adjust the temperature of an item or space automatically. Temperature controllers use on and off control and PID control methods to compare the actual input signal to the intended set point value and change the output signal appropriately. Used in various industrial applications, including plastic extrusion and food processing. LM35 is a temperature sensor with a direct proportional output to the temperature, often employed in temperature control system. So the problem statement for assignment 2 is to design a temperature management system for a manufacturing facility that uses an LM35 temperature sensor to detect water temperature precisely and communicates this data to a microcontroller. The microcontroller will then use the data to regulate a heater and chiller to keep the water temperature between 50 degrees Celsius and to 70 degrees Celsius. The system will also use an asynchronous serial communication protocol to send temperature data to a computer, allowing for real-time monitoring and control of the water temperature. The emphasis is on maintaining the optimal water temperature effectively and efficiently. So I will pass to my friend.
Hello doctor, myself Mugilesh Saminathan, matrix number CE200026. Now I'm going to explain about the proposed solution. So a temperature controller is a device commonly used to stabilize a heater or a cooler by comparing a received sensor signal with a set point and performing calculation based on the differences of the obtained values. A manufacturing plant's temperature controlling system uses an LPC1968 microcontroller for the given task. So a temperature sensor LM35 is used in a manufacturing plant to measure the temperature of the water and send the closest equivalent temperature reading in analog voltage to a microcontroller. According to the temperature reading, the microcontroller controls a heater and a cooler in the manufacturing plant to achieve the desired temperature between 50 Celsius to 70 Celsius. Simultaneously, the asynchronous serial communication protocol sends temperature data to the computer. For the second proposed solution, in the temperature control system, a switch is connected to the microcontroller to manually stop the system's operation. By connecting the switch, when an interrupt occurs, the microcontroller finishes the current instruction and begins the execution of an ISR, interrupt service routine, or interrupt handler. ISR instruct the microprocessor or microcontroller on what to do when an interrupt occurs. On the other hand, polling is a state of continuous monitoring. The microcontroller continuously checks the status of other devices, performing no other operations and devoting all its processing time to monitoring. So, interrupt can be utilized to solve this problem. The controller responds only when an interruption occurs in the interrupt method. As an outcome, the microcontroller is optional to regularly monitoring interfaced and inbuilt devices status such as flags and signals and many more. That's all from me. Next, I will pass it to my group member to continue this presentation.
Good morning, doctor. I'm Koglisharan. So today, for my part, I'll present on flowchart and coding. So for the flowchart, this is the start instruction. After the start, it will start the installation and to take start. It will read the analog measurements, which is the temperature sensor. So if the temperature is less than 50 degrees Celsius, the cooler will be turned off and the heater will be turned on. If it's not means, it will be goes to cooler off and heater off. And if the temperature is more than 70 degrees Celsius, cooler will be turned on and the heater will be turned off. So if not means the cooler and heater both giving the off conditions, then this instruction will be sending to reading to the PC. So for our coding, these are our codes. So this one is for the white integer. So for the white integer, uh, so these are the white instructions here. So below here, we have used the LPC 1768, which is the NXE compiler. So here for the integer main point, it will be like function takes no argument for the integer main point. This one declare it. So then here below, this LPC GPI input output and FIO CLI, where this FIO CLI is used to turn the heater and cooler off. It is used to drive an output configure pin to low logic. Then here, while LPC GPI 01 and 5 pin, wait for the start button. So next it will be read the analog ADC analog to digital converter. Here is the coding to start the conversion till 1 till 24, and this one is the for wait for conversion to finish, and to open the result shift right 4 by 12 bit. This one is we must to extract the result. So here we will declare the works, which is result will be times by 3.3 over 4096. It will be converted to voltage, and if the volts is less than 0.5, it will be 1 less than 20, the heater will be turned on, and 1 less than 18, the cooler will be turned off. So this one will set the pulse rate modulation 1, where it will set the 20% duty cycles and to low brightness. And second, if the volt is more than 0.7, we will set the pin here. So we will set the pin here 18 and 15. So the heater will be turned on, the cooler will be turned off. We will set the duty cycle to the 80%. So next, else, if for the input brace, we will declare this output 1 less than 18, the cooler will be turned off, and 1 less than 20, the cooler heater will be turned off, and we will set the pulse width modulation and its duty cycle by 50%. Then we will sending this result to the PC, where the result will be extracted for the first 8 bit, and the next result will be extracted if the more than 8 will be extracted the next 4 bit. So the total result will be the 12 bit result, where 8 plus by 4. So next is the main integer. This one is for function definitions. So the first statement here for the input output is we will declare 1 less than 18, 1 less than 20, then the heater and cooler off. And this one is for the pulse width modulation, we will set 0% duty cycle, and this one is to clear the interrupt instruction. So this one is for interrupt instructions, no interrupt instructions. So next will be for the void to the ADC peripheral. To enable the ADC peripheral by 1 less than 12 and 1 less than 20, to power on the analog to digital converter, and this one is to divide frequency by 1, and this one here to select the AD 0.04 for AD 0.04 for port 0.23. So next will be enable the integer 3 interrupt, and we will enable the falling edge interrupt at port 0.23 here. So this one is for rising interrupt. So next, port 0.18 and port 0.20, we will use port 0 for the GPIO in the unit, or for the what UART, we will use TX-J2, RX-J2. We will power on the UART cable as it's disabled by default. So this one is the result will be 8-bit character, one stop bit to access the edges. So next, this is the multivariance divided to the zero LHS, and this instruction is to disable access to divisible edges. So this one is to this void timer is to declare the timer mode in the ADC to power on for timer for 1 microsecond resolution. This one is for reset the timer counter and wait if counter is less than T. The last statements will be LPC behind con pin select for, where we set pin function to PWM 1.9 at port 2.0, and this function is to PW pulse width modulation 1 output, and this one is to prescaler the 1 microsecond resolution. This 10,000 is to set PWM cycle to 10 millisecond, and this 0 pulse width modulation less more than MR1 is to set the 10% duty cycle. So this one is to declare the latch value in MR1, memory 1, MR1 and MR2, memory 0, and this one is to reset the memory 0 and timer counter if it matches memory 0. So this one you need to enable the counter and the pulse width modulation. So that's all from me. Thank you.
Good day, Doctor. I am Sasmita Davanathan, Metric CE 2053. I am from Group 2. Today I am going to demonstrate assignment 2. Okay, first of all, I have to set the temperature as 0.45, which is 45 degrees Celsius, where it is less than 50 to 70 degrees Celsius. When I set this, and I have to run, turn on the push button at bit 30, so where it is set as a push button in bit 30. Okay, so we can see that the bit 18 is 0 and bit 20 is 1, where when the temperature is less than 50 degree, the heater will turn on and the cooler will be turned off. So the result we can see that 0 times 022e, and here okay, so here we can see that when the temperature is less than 50 degrees Celsius, the duty cycle will be 20%, and the brightness will be low. Okay, now I set the temperature at 0.55, which is 50 degrees Celsius, where it's between 50 to 70 degrees Celsius. And then I press the push button. Okay, we can see that there is the between 18 and 20 is 0, which means when the temperature is between 50 to 70 degrees Celsius, the cooler and heater will turn off, and the result is 0 times 02 AA. Okay, at here we can see that when the temperature is between 50 to 70 degrees Celsius, the duty cycle will be 80%. Okay, and here we can see that when it's between 50 to 70 degrees Celsius, the brightness will be high. Okay, now I set the temperature as 0.75, which is 75 degrees Celsius, where it is more than 50 to 70 degrees Celsius. And then, we can see that the bit 18 is uh, turned on and bit 20 is not. Where it is when the temperature is more than 70 degrees Celsius, we can see that the cooler will be on and the heater will be turned off. Okay. Okay, here at this point we can see that the result is 0 times 0.382, and when the temperature is more than 50 to 70 degrees Celsius, the duty cycle will be 50% and the brightness will be moderate mode. To reset this, we have to click the push button in bit 0 because in coding we declare that bit 0 as a reset. So, so we can see that there is a straight line as it is sure that it is reset. Okay, that's all from me. Thank you.
Hi doctor, my name is Suresh Anagrajan. My measuring number is AE180011. So I will explain about the conclusion of this project in group 2. So in conclusion, the temperature control system is intended to effectively manage the water temperature in a manufacturing facility. The LPC1768 microprocessor and the LM35 temperature sensor are used by the system to precisely measure the water temperature. In order to maintain the intended temperature range of 50 to 70 degrees Celsius, the microcontroller then utilizes the temperature measurements to operate the heater and cooler. The ideal operation of the manufacturing. This makes real-time monitoring possible and enables fast implementation of any necessary modification. Overall, the temperature control system is a good way to regulate the temperature of the water in the industrial facilities. To further enhance the temperature control system, however, a number of additional functions may be added where the first additional function is user interference. The addition of a user interface, such as an LCD display and buttons, may give operators a more simple to use method of adjusting the desired temperature and keep tracking of system status. Other than that, the additional function is alarms and alert by including alarms and notification in the event that a temperature veers outside of the target range. It may be possible to guarantee quick attention and remedial action. Lastly, is by adding automatic shut off, where setting up an automatic shut off mechanism in the event that the temperature veers outside of the required range or there are other system problems might help to avoid potential equipment or manufacturing process damage. The temperature control system might be made even more effective for ensuring the manufacturing facility operates at its peak efficient by incorporating these extra features. That's all from me. Thank you.